Hi, this is a bonus track on anaerobic digestion. What we'll do is we'll calculate the size for a fixed dome reactor for the example of a boarding school. Okay, this is the situation. A boarding school with 250 students and about 50 staff in a tropical climate. We have around 0.2 kilograms of wet waste, bio-waste, per capita and day. The TS is around 20%, and the volatile solids are estimated around 80% of the TS. The gas shall be used in the canteen of the boarding school. We want to build a fixed dome reactor below ground. The picture is here to illustrate how this should look like. And we know that the construction and operational skills are available on site. So, what should we calculate? First, let's look at the things related to feedstock. We have 300 people times 0.2 kilograms per day of biowaste per capita. That amounts to 60 kilograms per day of wet waste. And we have a TS of 20% of this wet waste. We'll shred this waste into small pieces and mix it with 1 part waste to 2 parts water so that we can create a slurry which we can feed nicely into the digester. So that means 1 times 60 of wet waste plus 2 times 60 of water equals 180 liters, assuming 1 kilogram equals to 1 liter. Next, let's look at retention time. For a digester in a tropical climate, we can assume a good retention time would be around 30 days. So that means 180 liters per day times the 30 days equals 5,400 liters, which are equal to 5.4 cubic meter. Now let's look at feedstock quality. We have 60 kilograms of wet waste. We have a TS of 20%, so that equals to 12 kilograms of dry matter. And we have 80% volatile solids, so times these 12 kilos of dry matter equals 9.6 kilograms of volatile solids per day per 180 liter. But now what we want to have is the amount per cubic meter. So the calculation we need to do is 9.6 divided by 180 times 1000 equals to 53.3 kilograms of volatile solids per cubic meter. Now let us look at the organic loading rate. The organic loading rate is the flow rate times the concentration divided by the reactor volume. The units are for flow rate, cubic meters per day, for concentration, kilograms of volatile solids per cubic meter, and for the reactor volume, cubic meters. Now let's plug in the numbers. So that is 0.18 cubic meters per day, that's the 180 liters, 53.3 kilograms volatile solids per cubic meter, that is what we just calculated previously, and 5.4 cubic meters, that's the volume that we calculated based on the retention time. That equals to 1.78 kilograms of volatile solids per cubic meter. And if you remember the slides that we showed previously when talking about the organic loading rate, for unstirred reactors, it is ideal to have an organic loading rate below 2. So we have achieved this in our calculation. Now let's look at the amount of gas that we expect. From literature, we can expect a biogas yield for vegetable waste of around 0.67 cubic meters per kilogram of volatile solids. So we have 1.78 kilograms of volatile solids per cubic meter, which we just calculated before, times these 0.67 cubic meters per kilogram of volatile solids, times the reactor volume of 5.4 cubic meters. That equals to 6.4 cubic meters per day. So that means we can expect 6.4 cubic meters of biogas production per day. Also from literature, we know that a biogas stove uses about 0.4 cubic meters per hour. So we have these 6.4 cubic meters per day. So we know that if we use one stove, we can actually operate it for 16 hours per day. Or if we have 4 stoves, we can operate them each for 4 hours per day. So that means we can actually cook quite a lot of food in the canteen of the boarding school. Now let's look at the total volume of the unit. In this specific design, we estimate that we need about 75% of the total volume for the slurry and 25% as gas holder storage. So we have 5.4 cubic meters of slurry plus an additional 1.8 cubic meters for the gas holder equals a total volume that we need of the whole reactor, which is of 7.2 cubic meters. So let's sum up what we calculated. We calculate the amount of feedstock, 180 liters. We calculated the volume of the digester based on the retention time of 30 days, which is 5.4 cubic meters. We looked at total volatile solids per cubic meter, 53.3. And to check on our organic loading rate, we calculate the organic loading rate, which is 1.78, which is nicely below 2, so fits nicely to our system. And we calculated the amount of gas, 6.4 cubic meters per day, and looked at how much a biogas stove consumes and calculated how long we can actually operate biogas stoves. Finally, we also calculated the total volume of the unit, also considering the volume that we need for the gas holder, and it amounts total to 7.2 cubic meters. So that was the calculation for a fixed dome reactor. I hope you can use it in any case in your country.